Apple Silicon is the new processor architecture used inside Apple's computer chips. Both the M1 and M2 line of chips use Apple Silicon, which were released couple of years ago respectively. Both of these lines have expanded since their conception. The M1 chipset branched out to be the M1 Pro and M1 Max as more powerful alternative to the M1. And similarly, there was an evolution to the M2 into M2 Pro, M2 Max and M2 Ultra chips. The Apple M2 used the same number of CPU cores as its predecessors, but improvement made to the architecture allowed for a significant performance boost. Apple Silicon uses ARM architecture. ARM architecture is a family of RISC instruction set architectures for computer processors. Now, Apple uses ARM based A series chips from its iPhone and iPad devices, so the transition allows Apple to provide cross platform support for apps across both iOS and macOS. ARM technology or architecture is renowned for offering excellent power and thermal efficiency compared to Intel processors. Now, uh, enough of Apple Silicon. In this video, I'm going to show you how you can run Mixtral LLM on Apple Silicon. Now, if you don't know what Mixtral is a mixture of expert LLM from Mistral AI, which is a French company. Mixture of expert means that it consists of 8 small LLMs of 7 billion size, and each LLM is expert in its own domain. And when they combine, they have this Mixtral model. Now, in order to install Mixtral LLM or to run this Mixtral LLM on Apple Silicon, you would need to follow the MLX framework. MLX is an array framework for machine learning on Apple Silicon, and Apple Machine Learning Research has devised it. And there are a lot of key benefits of it which you can read through on this GitHub repo, and I'll drop the link there so that you can read along further. Now, this machine learning framework, the great thing about is that it is very user friendly, but still it runs and deploy and even train the LLMs very efficiently. And as is the case with a lot of Apple products, they are not only very efficient and performant, but also they are quite appealing when you use them. So the user experience is quite nice. Now, let me show you the steps through which you can install the Mixtral LLM on Apple Silicon by using MLX. These are the instructions. First thing you need to do is to, of course, have an access to your Apple Silicon machine wherever your processor is running, and then make sure that you have at least 100 GB of RAM to run. Yes, it's not a cheap thing to run, unfortunately, but maybe in the future there will be a quantized version you could run, but still, as you can see very clearly here, you would need 100 GB of RAM to run this thing. Provided you have it, then the first thing you need to do is to install this git large file storage. Now, this git LFS or git large file storage handles large files by storing references to the file in repository, but not the actual file itself. To work around Git's architecture, git LFS creates a pointer file which acts as a reference to the actual file, which might be stored elsewhere. So you need to install this git LFS through brew. Once that's done, you need to download the model from Hugging Face. For that, simply just export these two environment variables like Mixtral model, which Mixtral model you are going to use. Like we are using this SOME of 8 into 7 billion. And then if you want to use the instruction fine-tuned model, you would use the instruct model. Just put it in this environment variable. Once that's done, simply run this command, which is going to git clone it from Hugging Face, and it will replace your Mixtral model environment variable with the value you put it in above. And then from there it is going to use git LFS or git large file storage to pull all the model with all the files to your local system. Now, once that's done, go to the MLS example Mixtral, this GitHub repo which I showed you earlier, and you need to maybe git clone it, or you can simply go in and go, once you download it, go to this MLX directory here, and from there you can use lot of models. Anyway, so I'm just going to show you from here in order to keep it simple. So from this MLS example, go to Mixtral and then convert and save the weights as numpy array so MLX can read them. Now this is a good point where I would just quickly describe what is the difference between NumPy and MLX. MLX is a NumPy-like array framework designed for efficient and flexible machine learning on Apple Silicon, and the Python API closely follows NumPy with a few exceptions. MLX has also a fully featured C++ API which closely follows the Python API. So MLX has also got composable function transformation for automatic differentiation, automatic vectorization, and also computation graph optimization. Also make note that computations in MLX are lazy. Array are only materialized when needed and not before, which really makes it very efficient. Also, operations can run on any of the supported devices like CPU, GPU, or whatever you are using it. Okay, now having said that, once you have converted and saved the weights as numpy array, then generate a 4-bit quantized model from here, and by default the conversion script will make the directory here, but you can also use these ones if you want to change it. And then in order to generate, all you need to do is this command. That's it. So you are specifying your model path which you just downloaded with your variable, and then mixtral.py. And then if you want to learn about more features, you can go with the help, but this is more than enough. And of course, if you want to use the instruction model, this is the format you need to use for the instruction models. So this is it, guys. This is how easy it is to run your Mixtral model on Apple Silicon. I hope this was useful. If you already are using it, let me know your experience, or if you get stuck or face any issues, please feel free to put it in the comment and I'll be happy to help out. And of course, if you like the content, please consider subscribing to the channel. Thank you very much.